All right. Hello, Chem 100L, and welcome to our next experiment, exploring density. All right, so I have my lab protocol right here. I have my data tables and such right here, and I'm ready to talk about our experiment. So density. Density is a measure of how much mass something has per a given volume. And so density is mass over volume. Now, the typical units for density are grams per milliliter or grams per centimeter cubed. Now, these are equivalent measurements or equivalent units because 1 milliliter is equal to 1 centimeter cubed. Okay? Now, this holds true because we've got relatively high densities for our liquids and our solids. Okay, so this holds true for liquids and solids. Now, where this doesn't hold true, though, are for gases. Now, gases have very low densities, and so gases are typically going to be in grams per liter. So this is for gases. Because we're dealing with solids and liquid solutions in this lab, we will be dealing in grams per milliliter or our grams per centimeter cubed, depending on what we're using to take our volume measurements with. Later on this semester in your Chem 100 lectures, you should be learning about gases, and that's where you'll use that grams per liter. All right, so the first step is we need to read through our experiment and do our pre-lab. And then we can look at our materials page on page 5 and start gathering all the supplies we need for our experiment. All right, so the first thing you need is this green bag. It is labeled Exploring Density. Inside this green bag, you will find 3 small objects. Okay? You will find an aluminum cylinder, a polyethylene cylinder, and an acrylic cylinder. All right? And then you'll need your 50 ml graduated cylinder, your electronic balance, pipettes, spoons, weigh boats, plastic cups, wax pencil, and your ruler. Some other supplies that you will also need: an ink pen to record your data, a pencil for doing calculations, and a calculator for doing your calculations. Okay? You'll also need, as listed here, some table sugar, sucrose, water, a non-diet beverage containing natural sugar, and some sort of graphing program. Now, we recommend you use Excel. Most of our stuff is written for Excel. We all typically, as scientists, use Excel, though I understand that most of you guys at home right now don't have access to computer labs and are probably going to use Google Sheets. So Google Sheets works. It's not as robust as Excel is, and it's not as easy to do some of the tasks on it as Excel is, but it'll still do what it needs to do. So you are welcome to use Google Sheets if that's all you have available to you. If you have Excel, though, I recommend using Excel. All right, the non-diet beverage that contains natural sugar. We're trying to figure out the percent sugar in our beverage. Okay, we're going to be doing an experiment to get the density of several different sugar solutions. And so that's using the same sugar that would be in a natural sugar beverage. So we don't want to use an artificial sweetener like would be in a diet beverage. So I've labeled these cups 0, 10, 20, 30, 40, 50, and 60% for my sucrose solutions. I have a cup here with my water because this is my water jug, and when I pour into a graduated cylinder, this is really hard to pour from, so I put into a cup first. And then this dark cup right here, this is my chosen beverage. I have chosen to use boring, generic, Safeway grape juice as my beverage. Okay, so I have stuff prepared here. I did some of the prep work before starting this video so that we don't have to wait for stuff to, too much stuff to dissolve to do our demo here. So before I do any more lab work, I need to get my PPE sorted back again. So I'm going to go ahead and button or snap up my lab coat because mine snaps. Okay, and then I will, once I'm done snapping up my lab coat, we'll go ahead and grab my goggles, and I will put those on. And then I will get a pair of gloves out. Okay, there's a pair. then I will be able to work on my experiment. Okay, now the first thing that you need to do is to start preparing your sucrose solutions. Even though activity 1 is getting the density of your cylinders, sucrose solutions take some time to dissolve, okay? So I've done the 0%, the 20, 30, 40, 50, and 60% solutions. Now, the 50 and 60% solutions especially do take a while to dissolve, and the 40 can take a while to dissolve as well. For most liquids and solids, if we increase the temperature, we increase the solubility because there's only a finite amount of a particular solute that we can dissolve into a solvent. So in this case, our solute is the sugar and our solvent is our water. And so as we get closer and closer to that finite amount that'll go into a particular solvent, it gets harder for it to dissolve. Now, if we increase the temperature, then we can get it to dissolve better. So if you do decide to use the method that your lab manual suggests with heating stuff up in the microwave in short bursts, make sure you do so in another container because these plastic cups, I wouldn't recommend, sticking those in the microwave. If you do set everything up and realize that your 40, 50, 60% solutions are taking a really long time to dissolve, all hope is not lost. There is another option. Okay, what you can do is you can create a water bath. You can take a shallow dish like I have right here, and you can heat some water. I wouldn't heat it to boiling, but you can heat water up. And then what you can do is you can stick your cup into your water bath, and that will gently heat the solution in there. You can swirl it while it's in there. You can stir it with a spoon, and the heat will go from the hot water here to your colder water in your cup, and that will help facilitate it dissolving faster if you set everything up before you tried using a microwave safe container to heat up your stuff. Okay, so that is one option as well. So I did not make my 10% solution yet. I'm going to do that as a demo with you guys. So I'm going to get my balance out. I'm going to turn it on. I'm going to get a weigh boat. I'll put the weigh boat down, and then I'm going to hit the tare button. That's going to cause my balance to read 0. So now all I have to do is add my sugar to my weigh boat and watch what my balance says, and that'll tell me how much sugar I have. Okay, so that spoonful is 3.53 grams. My instructions say I need 5.5 grams. That's 5.25, so I'll go a little slower. And there we go. There's my 5.5 grams. Okay. To pour this into my cup, I'm going to take my weigh boat. I'm going to pinch it. And I'm going to pour it. Okay. And then I can put my weigh boat off to the side so that I can wash it when I'm done. Tare my balance and turn it off for when I need it later. All right. And now I'm going to take my graduated cylinder. And again, it's easier to pour from a small cup. So I've poured my water from my jug to my small cup. And now I'm going to get my 50 mils. Okay, and there's my 50 mils. So now I can go ahead and pour that into my cup. It's marked 10%. And I can use the spoon to stir, or I can swirl it around like this and let it dissolve. Okay. Now, as I'm dissolving this, a couple notes. Your 40% solution requires 33.4 grams of sucrose. That will fit in the weigh boat. But your 50% and your 60% solutions require 50 and 75 grams of sucrose, respectively. That's not going to fit well into the weigh boat. So what I would recommend is weigh out 25 grams, pour it in your cup, weigh out the other 25 grams, pour it in your cup, do that for your 50, and then for your 60%, weigh out 25 grams 3 times, and that'll fit in your weigh boat. But if you try to do all 50 or 75, you'll make a sugar mess everywhere. Okay, this is almost dissolved. Here. All right. It's just about dissolved. I'll let that sit for now. I'm going to move all this stuff out of the way. Okay. And you'll notice, I don't know if it's very visible on the video, but as we get to the more concentrated solutions, it is a little yellowish looking, but it is dissolved because you can see through it. If it is not all dissolved, it will definitely be a very cloudy solution, but it's okay if it's slightly yellow as long as it's clear. Okay, so the first thing that we're going to determine are the densities of our little solids here. So what we're going to do is we're going to take our ruler and we'll use the metric side. Okay, we're going to measure our height and our diameter. So for my height, I'm going to put it up there. For my diameter, I'll put it like that. Okay, and so for my height, I'll measure it here. Again, we want to use our metric and we want to do it in centimeters. Okay, so my cylinder looks like it is about 1.25 centimeters is what I'm going to estimate mine at. Okay, so that's my height. Okay, and then my diameter. Mine looks like it is, I don't know that line, so mine looks like it's 1.20. Okay, and then diameter is twice the radius, so I need my radius. So I'll do that in a minute, but it's always better to get all your data first and then to do your calculations, okay? And I also need my mass. So I'm gonna turn my balance on. Make sure it reads 0, then put my cylinder on there, and I have 4.29 grams for my mass. All right, so I've recorded all of my data down. And so now is when I can take my pencil, all right, and I can show my calculations. And so for my radius, I'm going to take my diameter of 1.20 and divide it by 2. Okay. Okay, so again, for my radius. Okay. Okay, and so then if I can't do that in my head, I can take my calculator and I can do 1.20 divided by 2, and I get a radius of 0.60 centimeters. Okay. So then I can take my pen and write that in my radius here, so 0.60. And then I want to calculate the volume. So we have an equation here of volume equals pi r squared h. Okay, and so I take pi. So I can either use the pi button on my calculator, or I can use the 3.14159 number. And so I just plug this in. So I have pi times 0.60 squared times my height, which was 1.25. Okay. And then do that real quick. So we'll do our 0.6. And then the 1.25. All right, so I'm gonna get 1.41. All right, now my units here. Okay, so I have pi r squared h. So pi is unitless. Okay, my radius is centimeters. So I have centimeters and squared. So it's centimeters times centimeters. My height is also centimeters. So I have centimeters times centimeters times centimeters, which is centimeters cubed. So 1.41 centimeters cubed. Okay, so that is my volume. And then now from there, I can go ahead and calculate the density. Okay, and so again, that's our grams per milliliter or grams per centimeter cubed. So I'm going to take my 4.29 grams over the 1.41 centimeters cubed. And I'm going to get a density of 3.04 grams per centimeter cubed. And I can write that down, my density spot. Okay, so again, anything I fill out on my data table, I'm doing in ink, and any of my calculations that I'm showing, I do in pencil. Okay, all right, so that is how we do the measurements for our objects. So I'm not going to do the other two. Let's go ahead and move on and talk about the density of our sucrose solutions. Okay, so what we want to do is get our data table up for our solutions. So the first thing we need to do is weigh our graduated cylinder. Okay, instead of tearing, we're going to just be doing a subtraction. So I'm going to put my graduated cylinder down, and I have a mass for my graduated cylinder of 29.47 grams. So on my data table, I have percentage of sucrose, volume in milliliters, mass of solution plus graduated cylinder, mass of cylinder, and mass of solution. So this is just my cylinder, and it is 29.49 grams. Now I'm going to be using the same cylinder through all the rest of my measurements. So in my 0% here, for the 5, 10, 15, 20, 25 mil volumes, I'm going to write down the same 29.49 grams for my graduated cylinder. So that's not going to change. Okay, so now what I need to do is I need to get my cup that's labeled 0%. Okay, now I want to put in 5 mils. So the easiest way to make sure that you're getting a good milliliters is to go ahead and use your pipette, because we want to make sure we get that 5. So I'm going to use my pipette to add in my 5 milliliters. And I got down eye level because I want to get to that 5.0 mark. Looks like I need another drop or two to do that. All right, there we go. I have my 5.0 milliliters. So now I'm going to look at my reading, and I have 34.47 grams. Okay, now I'm going to do this again. I'm going to go from the 5 mil mark to the 10 mil. So I'm not going to, pour anything out. I'm just going to add, because my next volume is 10 mils. So I don't need to pour out and then add in 10 mils. I just have to add until I get to 10 mils. Okay. All right. And then I can read my mass. So I'm going to get 39.43. Okay. And I'm going to keep doing that until I've gotten to 25 milliliters of water. Now, to get my density, okay, I need grams of my solution over milliliters of my solution. So I have mass of solution plus graduated cylinder, and then I have mass of cylinder. So in order to get the mass of my solution, I'm going to take the mass of solution plus mass of cylinder and subtract the mass of just the cylinder from that. So for my 5 mil volume, I'm going to take 34.47 minus 29.49. Okay, so 34.47 minus the 29.49. And I'm going to get 4.98. And that's good, because we said that the density of water was approximately 1 gram per mil. And I have 4.98 grams for 5 mils of water there. So that's not bad. So I'm going to do that for all of my measurements. Now, I recommend getting all of your measurements first and then calculating your mass of solution when you're done. So I would just bust out all of your measurements and then do calculations. All right. So you'll do that for the 0%. Now the 0% is just water. And so cleanup will be easy. You just need to pour this out. And then after you pour it out, then reweigh it for your 10% sucrose solution. So when you pour it out, try to shake it out to get as much of the excess water out of it as possible. That way you're not diluting your next solution, okay? And then you'll get a mass of the cylinder before you add any of the 10% sucrose solution. So you'll get that mass and you'll use that same mass for that 10% like we did for our 0%, and we'll get all of those readings. Okay, and so you're going to do that for the 0, 10, 20, 30, 40, 50, and 60% solutions. And then what you'll be doing is you will be graphing this. Okay, rather than calculate the density of each of these by hand, we have this data table. Okay, right here, data table 3 has percent of sucrose in solution, equation, and then density. Okay, so what you'll be graphing is you want to go ahead and graph your mass versus your volume, okay? So our mass versus our volume. Okay, and this is Y versus X. All right, so my mass in grams will be on my Y-axis, and my volume in milliliters will be on my X-axis. And so I'll get points along the way. And then using my graphing software, I can get a line of best fit. They'll go through there, okay? Now, we want to try to set our line of best fit to not have a y-intercept. Because remember, the equation of a line is y equals mx plus b, where m is our slope and b is our y-intercept, okay? Now we are looking at density. So if I have a mass of 0, should I have any volume? No, I shouldn't, okay? So if there's no mass, there should be no volume and vice versa. So we shouldn't have a y-intercept because it should go through the origin. It should go through 0, okay? So we'll get this, and then using our graphing software, we can actually get it to display the equation of a line on our graph. And so for density, our slope equals our density. Okay, so when you get that slope, that will be the density of your solution. So you'll be able to do that for all of your sucrose solutions. Okay, then the next part is you'll want to go ahead and get your densities of your solutions and the densities of your cylinders before you do activity 3. Activity 3 wants you to look at the densities of your 3 cylinders and the densities of your solutions and make predictions about whether or not each cylinder will sink or float in a respective solution, and then test that. Okay? And I don't want to ruin your predictions, so I'm not going to drop any of my cylinders into any of my solutions because I don't want you to be influenced by what you've seen in this video when you're making your predictions. Okay, and then the very last part is going to be your beverage. So doing what we did with our sucrose solutions, you're going to do that with your beverage. So the last data table has volume 5, 10, 15, 20, 25, mass of solution plus cylinder, mass of cylinder, and mass of solution. So you're going to do the exact same thing we did with each of our sucrose solutions. You'll mass out your graduated cylinder all by itself, and then using a pipette, you'll add in 5 mils and take the mass. Then you'll add in another 5 mils, get the mass, and do that until you get to 25 mils. And then you can get the masses of each of those solutions. And then you can graph that and get the density, okay? Now, using the information that you achieved in the sucrose portion, you can make another graph that graphs the percent sucrose and the density. Then you can take the density of your beverage that you chose, and using the graph that looks at the percent sucrose and the density, you can then figure out what the percent sucrose is of your chosen beverage. All right. And so that is our experiment for this week, is we're going to do a lot of stuff with density and then figure out if we can figure out the percent of sugar in our particular beverage. Now, most beverage containers do list the percent sugar in the nutritional information. Okay. But keep in mind that what this is it's not the percent by mass. So if I look on this, it says nutrition facts, 8 servings per container. So if I look on here, it says percent daily value. This says that it has 14% my daily value of carbohydrates. It does not mean that this is 14% sugar. It means that if I drink a glass of this, I have consumed 14% of my daily value of carbohydrates as recommended by nutritional experts. So don't look at the percent on your beverage container and the percent that you get from this and think that you did something wrong, because this is going to tell you the percent by mass of sucrose. This tells you the percent of your daily value that you're consuming. So they're 2 completely different percents. So don't get confused by what's on the label once you get your percent from your experiment. Okay, so again, that is our experiment. Remember, record your data in ink, do your calculations in pencil, make sure you're wearing proper PPE, and when you're all done, these are just sucrose solutions, and that's a beverage, so everything can go down your sink. Wash everything really well first with tap water, and then give it a rinse with your deionized water when you're all done to make sure that none of the residue from the tap water gets stuck on your glassware to contaminate further or future experiments. All right. So as usual, if you have any questions, you can email me, shoot me a message on Canvas, or show up to my office hours, and I will do my best to answer your questions and help you out. So I hope you enjoyed this experiment. I hope you enjoy testing your beverage to see what percent of your beverage is your sugars.